worldwide propagation is on a given band. It's kind of interesting. There's software to go with it. It tells you, which beacon is transmitting now, what you should be listening for. So those are very helpful. And of course, the reverse beacon network will tell you how your signal is propagating in real time too. You just have to send test or something like that, or CQ, and go look at some stations all over the world and see if you were heard. All right. Take advantage of the digital modes. Now here's a chart from the WSJT documentation, and it shows the JT65, FT8, and FT4. I also added CW in there. How long does it take to do an exchange on CW? Probably about 15 seconds. You're clipping right along, but you can do it in about 15 seconds. And based on my ability to copy CW with noise, the signal noise limit in 2500 hertz is about -12. That's my ability. In 2500 hertz, I can copy a signal at -12 dB signal and noise. So I did it in 2500 because that's what all the digital modes are listed as. For example, JT65 took about 4 minutes to make a QSO. Its signal noise limit was -25 dB. So it had about a 13 dB advantage over my ability to copy CW. That's quite a bit. Of course, JT65 took too long, so that's why FT8 came along. Hi, kitty. It takes about a minute to do a FT8 QSO. Oops. The signal and noise limit for FT8 is about -21 dB, which says it still has a 9 dB advantage over my ability to copy CW. That's nothing to sneeze at. And then wanted a shorter duration QSO, so here comes FT4. Takes about 20 seconds. Signal and noise limit's about -16. Still has about a 4 dB advantage over CW. So you can see what's happened. To make QSOs faster, you give up sensitivity. Okay. FT8 took off in mid-2017, and it leads the pack. Looking at statistics on Club Log of reported QSOs on the various modes, sideband, CW, RIDI, PSK31, etc. FT8's just way in the heck up there. Now, is there going to be another digital mode past FT4? Well, it looks like if you try and speed it up too much, we'll kind of be back to CW, and the signal noise limit might be very equivalent to CW. So I don't know if Mr. Taylor is working on something besides FT4 or just trying to improve FT4. Well, we'll have to wait and see, I guess. Okay, short-term enhancements. I mentioned that earlier. And, we don't have daily propagation predictions. It's okay, Tiger. In other words, today's ionosphere does not correlate well with today's sunspot number or 10.7 centimeter solar flux. That's an interesting comment. Why not? Because there are two other parameters that can modify the amount of ionization. One of them is geomagnetic field activity. We kind of have a decent understanding of this. There's a website that takes the K indices and predicts what the F2 region is going to do. Mel has a copy of this presentation, so I'm sure you can get that from that presentation that he has. The other factor is events in the lower atmosphere coupling up to the ionosphere. There's a lot of research going on in this area. For example, we can see signatures of earthquakes in the ionosphere. They're kind of small. Other large weather events, hurricanes, they're pretty big. They dump a lot of energy in there, and we can see signatures from them. The 2011 earthquake in Japan generated a very nice tsunami that propagated across the Pacific to the west coast, and we could even see perturbations in the electron density because of the tsunami. Pretty interesting stuff, and it's really eye-opening to see some of the stuff that, you know, decades ago we never even thought of. So pretty good. So here's a good example of a short-term enhancement. It's because our predictions are statistical in nature over a month's time frame. Like I said, we don't have daily predictions. We have predictions that are statistical over a month's time frame. Now, a great example of this was the 2018 California QSO party, and that's what's depicted in the picture. W6 to the Midwest. That's Northeast Indiana, Fort Wayne. And luckily, the Boulder ionosonde was right at the pretty much the midpoint of that path, so we can take a look at its data to see what happened. And there's the data. On the left, that's the MUF for a 3,000 kilometer path if Boulder was the midpoint. That's for October 2018 for the first 8 days. And you can see in the first 6 days of October, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, the MUF was only about 20 megahertz. So that says there was no 10 meter propagation. And indeed, I did not hear any W6s on 10 meters on the first day of the California QSO party. But on the second day, on Sunday, on the right is what happened. The K index spiked up. It didn't go, you know, way up to 9 or anything, so it wasn't major, but it was enough that ionization got rearranged. And what it did, you can see on the 7th, the Boulder ionosonde reported an MUF, a maximum usable frequency, over 30 megahertz. That opened up the path from Midwest to California, worked a lot of W6s. So there's the good thing is check the higher bands when the K index spikes up. Cycle 25 predictions. Okay. The last solar minimum was long. This solar minimum looks like it's going to be just as long. And what does that tell us about the next maximum? Well, here's data from all 24 or all solar minimum periods and the next solar maximum. You can see is the longer we spend at solar minimum, it's very likely that the next maximum is going to be small. It's not a perfect correlation, but it's kind of an obvious trend. So what this suggests is our long solar minimum right now, we're going to have a small cycle 25. And I think most solar scientists are in agreement with that for various reasons. Cycle 25 sunspots showed up in, the first one was December 2016. And there were a couple more, but they were so small and of such a short duration that no active region number, AR number, was assigned. But finally, on July 8th, 2019, a longer duration, larger cycle 25 sunspot showed up. You can see it circled in yellow. It was assigned active region 2744. And I'm pretty sure that's going to be called the first official cycle 25 sunspot. So cycle 25 is alive, just like the old Frankenstein movie. Here's NASA's prediction of cycle 25. They made this prediction in December, last December. They say solar minimum is going to be in April 2020, plus or minus 6 months. So they have a little bit of a leeway there. So that means they're saying solar min could be anywhere from October 2019 to October 2020. We'll have to wait and see what happens. Hopefully we won't be going too much longer and things will start going up. They also predict that the peak's going to be in July 2025, plus or minus 8 months, at a smooth sunspot number of 115, which, hey, cat wants some attention here. The Peak's going to be in July 2025, and it's going to be kind of similar to 24. Now, you remember cycle 24 had some good 6 meter and 10 meter propagation around solar maximum, so we'll probably expect to see similar conditions at cycle 25 when it peaks, especially during the fall and winter months. Okay, sunspot number confusion. Well, we have 2 sunspot records. Starting in 2011, there were 4 workshops to determine the validity of old sunspot numbers. So why was that question? Well, you got to remember, how do we count sunspots? Well, humans do it, right? And we're biased. There's no doubt about it. There's also, how good are telescopes? How good is the viewing? Clouds and all that kind of stuff. So all those old records were evaluated, and new data was compiled. And the biggest issue was the old sunspot numbers had a factor of 0.6 applied. In other words, if they thought the sunspot number was 100, it was reported as 60. So that really messed stuff up. And the new sunspot record was generated. It's called version 2.0. The old one is version 1.0. Basically, it took out the 0.6 scale factor. So that says version 2 is higher than version 1. The Royal Observatory of Belgium began reporting the version 2.0 numbers on July 1st, 2015. And that plot below shows the difference in the version 2 and the version 1 numbers. Blue is the version 1, the old data. Red is the new data. So you can see that things got bigger. And that pretty much applied to the records all the way back to 1750. So if you look at the Space Weather Prediction Center's website, here's an excerpt from it. They've got various columns of data. Observed is the monthly mean. In other words, take all the daily values and average it over the month. The columns that are labeled SWO, Space Weather Operations, are version 2.0, and the RI columns that are reported are the version 1. So we see 2 different sunspot numbers reported. Now, that can be confusing, but what the Space Weather Prediction Center plans to do at solar minimum is change their RI reporting over to the version 2. So everything should be close and we don't have this confusion, hopefully. Well, I kind of lied. You got to remember our propagation prediction programs. They were correlated using the old sunspot numbers. Now we got new sunspot numbers, which are higher. So what that says is if you use a version 2 number, it's going to give a more optimistic prediction, which I guess that's good. It's better to predict an opening that doesn't happen than not to predict an opening that did happen. I think I said that right. So how much is that going to matter, the version 2 and version 1 numbers? Well, it kind of depends where we are in a solar cycle. If we're at solar minimum, version 2 and version 1 are going to be, 0 is 0. Not much of a difference. Most of the difference is going to be around solar max. It could be about a 1-band difference. In other words, the prediction may say 12 meters could be open, but in reality, only the 15 meters. So one way to mitigate this is when you're using VOACAP or W6EL prop, you're going to take the version 2.0 number that Belgium reports, just multiply it by 0.6, and then your correlation should be back to what it used to be. So here's a summary. Looks like this solar min will be a long one. Official minimum soon or a bit later. Well, we'll have to wait and see. The low bands in 20 and 17 will still offer worldwide DX QSOs. There's still enough extreme ultraviolet to keep 20 meters open. And if you ever look at Packet Cluster, I'm sure you do, you can see there's lots of 20-meter activity. Don't forget sporadic E in the summer. in December. Look for occasional openings on the 15, 12, and 10 to the south and to VKZL. Probably just like those of us here in northern Indiana, you guys have to look probably for a sporadic E link to get down farther south. So it happens. Be aware of short-term enhancements on the higher HF bands and on 160 when the K index spikes up. You might be pleasantly surprised and catch something that you didn't expect. Now, as we're coming out of winter, there's more sunlight. You know, the sun's moving up into the northern hemisphere, so there's more sunlight over the North Pole. So that means the MUFs are going to go up, maximum usable frequencies. So look for 20 meters over the North Pole openings. The digital modes are going to make this solar minimum the most active in history on the higher bands, so take advantage of them. And cycle 25 is likely to be small, just like cycle 24. And like I said, you should still watch for great 10 and 6 meter openings in the fall and winter around solar maximum. It may only be for a year or two, but they'll probably be there unless cycle 25 turns out to be a real dud. And again, all we can do is wait and see what happens. So that's all I had, Mel.